Today I would like to talk about audio amplifier, specifically class D amplifier, and you can see the circuit here, 3 circuits, and it is very simple amplifier. The quality is also nice. Now here's the full circuit, and I've forgot where I've kept my tripod, so I'm holding the camera in my hand. So the first circuit is just amplifiers. This one is a non-inverting amplifier. This transistor is this op amp is an inverting amplifier. Basically this one amplifies the main signal and its output is taken as the input by this inverting amplifier from the non-inverting amplifier, and it inverts the signal. But since the output of the op amp stays at 6 volts from 12 volt supply, so it is half of the supply voltage, so it's not much of a problem and it works nicely. Then there can be some buffers, and then there needs to be a comparator. These two are the comparator. Here's the triangular wave generator. It generates a triangular wave, clean triangular wave at 54 kilohertz or 500 kilohertz. It basically it can be set by yourself. I am using 54 kilohertz because at higher frequencies the output of the op amps are not great to look at, and it's not a perfect waveform to drive the gate, not perfect signal to drive the gates and the transistor. So I'm using 54 kilohertz where the edges are very sharp and the MOSFET turn on and turn off immediately. So the output is taken, basically it is driving the MOSFETs high side and low side. Basically high side is boost strapped by capacitor and transistor here. So basically what happens is that when the MOSFET goes high, basically when the op amp goes high, the MOSFET turns on and this transistor also turns on, and it basically discharges this MOSFET's gate, and the op amp charges this MOSFET gate so it can go high. And when it goes high, when this side goes high, imagine this side goes low. Basically this side is now low, so this side needs to go high. So basically what will happen is that the comparator will turn off, which will discharge this MOSFET gate, and basically this transistor will also turn off. So what will basically happen is that this MOSFET will start to turn on, and basically when the MOSFET is turning on, the source of the MOSFET will go high, and it will basically provide some, basically it is a feedback from this capacitor through this resistor, and basically as the MOSFET goes high, the gate of the MOSFET will also go high, and when the MOSFET fully turns on, the gate of the MOSFET also basically fully charges. So that's how it is working. It is a bit complex to explain, but it is actually easy. Basically the MOSFET is itself turning it on. Now here's the amplifier working, and here I'm probing basically the output of the amplifier. Basically I'm probing at the output here and here. So I would like to play the song now. Now is the output of by the filter, LC filter. Now the channel 1 of the oscilloscope goes here, and channel 2 of the oscilloscope goes here, and here's the oscilloscope. You can see the switching. Let's play the audio now. And now let's just see channel 1. You will see the duty cycle changing and increasing. And it is bootstrapped. I don't know what is this notch here, but then it stays stable here, and the transistors are not getting hot, not any hot. And if this was class AB audio amplifier like I've built here, you can see transistors here, big transistor, some control circuit, it will get hot, very hot. And since it is class D, I don't have to worry about biasing and such, transistor biasing and such, and it works nicely now. Thanks for watching the video.